Okay, the computer's here. Okay, just want to make sure everybody can hear me. Sandeep, would you like to hop to the front row so that I don't have to put on my speakerphone? Yeah, that'd be good. I think you're in my group. Yeah, yeah. Okay. Ah, why am I here? Nope. All right, you should be seeing my screen. Okay. All right, let's go ahead and get started. I think this is you, right, Jonathan? Yes. Yes. All right. I am recording. I am. Yes, students on Zoom, if you can't hear me clearly, let me know. I know this laptop doesn't really know as the minute I turn my face, the audio turns bad. So I'll try to stick my face into the screen. Okay, so if I wanted to move the biocell below to the northwest, how would I shift to 1107 contour in the medium? How does the cell work? Not exactly sure what that means. Let me go through the comments here. How does this work? Is there any reason to wrap a berm around the north side of the cell? Not really, because it's high. So it doesn't really go over that way, water. How should I label where the trench drain hits the curb? If you have a trench drain, CC, it's not technically a curb cut. I'll return to that. Need RDI here. Nope, you don't actually need an RDI here because water will just keep flowing down if it doesn't get into the medium area. Okay, to have a closed 104. Yes, you will have a closed on 104 there. And swell slope changes 2 to 3 times. That's okay. You could also try to space them more evenly, but I don't think that's critical. Okay, so that's all the question here. No other ones. All right, let's start from this one. If I wanted to move the biocell below to the northwest meaning here, this one needs 1, 2. So the whole thing would be full of bioretention, depending on how you divide it into multiple units, right? This one definitely has 1 because you have water going into the bioretention from this area. So I'd say you would have at least 3 or 4 over here because you have about 2 foot of a difference in elevation. Now, I would say every half a foot, it makes sense to create a separate cell because you don't want them to be kind of substantially different in elevation from cell to cell. Even those differences out would be a good thing to avoid some of the cells getting too deep. So that could I would at least create 1 here. Maybe no, every half foot contour you can have 1 cell actually. 1 here, 1 there, 1 here, and then 1 there. So you would have a total of 4 inside this medium. Let's take a look at how this cell work. So 1107, 1106 point. Yeah, go ahead. Yeah.
So just for me to know in theory, we have the 107.
Yes.
And I am
Oh,
sure what-
okay.
how if they have like auto process a certain thing, right, based on the slope of the parking lot, you can't shift it up. You can move the contour in between those junctions with the curve, right?
Yeah, you can actually do this. So the blue line, the only thing that needs to stay the unchanged is that point, connection point, that connection point, that connection point, and that connection point. So they can all be curved, and it can be dragged up if you want to. Right. Keep the distances, keep the distance between these contours so that you would have a shallow, gentle slight slope. Otherwise, how you connect these points, they're totally flexible. Yeah. All right. So that's basically the question, right? Okay. Let me save that one. Then I'll clear, and then let's check the elevations. So 1106.334, and that's your DI, and that's your RDI. Your RDI is a little lower than that. That's cool. Yes, because that's the dead corner. If it doesn't, well, if you have a DI, then you don't need an RDI. You only need one of those two. Yes. Yeah, so you can remove that RDI. Then you have a 1106 contour, that's good. And then 1105.3, meaning that you have 1 foot of a difference. So I think this works. And high point works to your berm. Your berm would be on the side, so you need to add a few more HP. Yes, this is the lower side. And yeah, just need to make sure that it doesn't go over to kind of spill over to that side. You can enlarge the area like this. Not doing a great job. Yes. What you could verify would be doing a cross section. And find out the lowest curb height, which is at this point. So that is 1105.81 on the parking lot. So the curb will be 1106.3. So yeah, as long as basically, what's that? That's that. This is at roughly the same height as your curb cut over here. So this one, the curb here, top of the curb is about 1106.3. And here, no, bottom of curb. Oh, sorry, top of the curb is 1106.3. Here, the bottom of the curb is 1106.3. So if I were to draw, your 1106 it's your water, that's your water line. Let's see. Your water line is over here. Your bottom, you have a 1106, then your bottom is at 1105.3, somewhere here. So you're roughly creating something like this, right? So we'll just need to make sure there are multiple high points along this way if you are trying to extend it over, right? So that is this curve here. This curve here is about 1106.3. So that if you were to extend over, the high point would be 1106.84, which is right on target. Yeah. So anytime you have some concerns, you draw a cross section and find out where water is the where the curve is the lowest to where it's likely to spill out, then you should be able to get the right spot elevations. Yes, that applies to the berm. Ideally, you would want this to be gentle and 2.5 to 1, but no, we will allow up to 4 to 1. Normally, they go to 3 to 1 on our campus. Yeah. Okay. So that's that part. Yes. Yeah. Okay. All clear. Yeah. Mm-hmm. Yeah. You could, yeah. But you just want to make sure that is actually the case. Yeah, yeah, yeah. Yeah. For instance, if you dig deeper, then you know, if we dig deeper and we have an RDI at this level, it won't spill anyway, right? So that RDI becomes the mechanism for directing anything that would likely go over the curb into the pipe. So I think it really depends on the relationships between the curb cut, your RDI or your DI, and the bottom of your cell. Yeah. It depends. In a pretty ultra urban settings, there sometimes you don't have the space. So you kind of have to opt for a vertical wall, 90-degree vertical wall to maximize the volume that you can retain. So it really depends on the setting. For in this case, I think you're still going to be able to, that is about 10 feet, right? You're still going to be able to achieve a relatively gentle side slope. And I think that's better for aesthetics, for safety, and for cost. Building those vertical walls is actually very expensive compared to earthen side slopes. Okay. We'll move forward to the next one. So we have a curb cut, we have a trench drain. Your trench can actually stop here. Oh, your trench can, that line is not necessary because now that your contours are turned or angled toward your sidewalk, you don't really need this portion to collect water. This will serve as your curb cut, but it's not necessarily a curb cut per se because you don't have that opening, right? Yeah, so basically this goes into this the trench drain. I think using TD would be okay. TD. Well, and then it's actually a bottom of trench drain. It's also a bottom of curb. So as long as the I think it will be fine. Bottom of trench, right? It's also the bottom of curb. It's the same thing. It's the same elevation as your bottom of curb. And then, yeah, this goes over, that's a fast dropout area, okay. This one would actually be a CC here. Yeah, that one is a curb cut. And not really. This is the same elevation because it's it's parallel to your, because this goes in. Now, if we again draw, they are at the same elevation. Your water goes to the bottom of a curb, and then it drops down to a trench drain. And the trench drain, the bottom is actually slated, sloped. So basically you're dropping. So the BTD here is not necessarily the water level. So here, you would have an elevation there, an elevation at the, you need to know the elevation of the bottom of the trench drain, and then a 1.5 percentage of slope along the trench drain, using that distance to calculate where water comes out. So yes, you would have a the bottom of curve elevation, but in fact, your water goes down, enters the cell at a lower elevation because of the trench drain. Does that make sense? Yeah. Yes, is the bottom of the trench drain. Yes, so I take this back. This is not correct. That's actually should be the top of TD. TTD / BC. Yeah. So if I redraw this to avoid, so that's your trench drain. And these two, the bottom, you don't have to specify. You need to use that for calculating where water comes out here. That determines the entry water level here, which means your LP is going to potentially be half. The circle of the bottom left, that is the bottom of trench drain. Yes, 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 that's right. Okay. This one is a curb cut. Yeah, if you think about the surface, the face of the curb, you don't necessarily have a cut here. It's actually a, this portion is closed. Does that make sense? So the face of the curb here, you have the entry of the water, but you don't necessarily cut the curb open. There's no segment of that open gap. It's the face of the curb is closed. Yeah. You could have a curb cut here. Yeah, because the curb cut then here, if you think about that curve, it doesn't necessarily have to be open, but it can be open. But for that one, it couldn't be open. Because if it's open, no, for this one, people walk on this one. It doesn't make sense for that one to be open, but this one, it can be open, but it also doesn't have to be open because its function of collecting water, not only from this watershed, but also from this watershed, it's also performed by the trench drain itself here. So the curb here does not necessarily have to be open, but it can. But here it cannot be open just because you can't have an open curb while people are walking on it, right? Yeah, yes, yeah. Yes, that's right. Yep. All right. So let me try to clear this. Is there any reason to wrap a berm around the north side of the cell? No, I don't think it's necessary. It's actually going up. If you have one more, the berm is always going to be between the cell and the lower elevation. Yeah. No, you don't need one because it will keep flowing down. And this is a 10, close 104. Oh, 104 here, right? Yes, that's right. Yes. 104 is close there, right? Okay, let me zoom out. I think those are all the questions. Oh, this one. Okay, so now I think we're missing a contour somewhere. 1106 and 105. This is very flat. 105, 105 again. And then if this is, so in this area, it seems in this area it's going lower than 5%. Oh no, 2%. So that's why I think you would have your 105 will be in a different position, because there's a need for a you have a 105 over here as a closed one, and then 106 goes out here. So your 105 needs to be somewhere here. Nope, that may be too close. Let me think. Based on, it might be somewhere here. You could have one more here. And then let's see. Our swell, let's find the swell line first. That needs to be sort of like this. So is this, I think you will need to specify that center line, because you would still have a swell up until it gets into the cell, right? So I don't know exactly where that's located, but it should be going into the cell. And then you calculate that entrance elevation somewhere here to know what that elevation is, and using that as the indication of relatively higher elevation on the bank, right? So let's suppose this is where 105 goes. That's too heavy. If this is where 105 go to shape this swell, then you might be at 1105 right here. Then you have a 1104. You have another 1105. Could we get rid of actually the 1105 over here? Basically, your 105 would be one of this. And then you have a 104. That's your lower elevation. You have an RDI of 105, making sure it stays in 1 feet. And then your 104, yeah, the difficulty is having another one on the higher side, so it doesn't keep flowing down. So how should we make that one? Okay, if we let that one go around, give me a time to think about this one. We need one that connects here, making sure this is, oh yeah, you need one more here that use that one. We erase that one, use this. Yeah. Well, 5 wraps around. Let's see, let me try a few things. Yeah. Does it not need to go into the vegetated area and back out?
If you look up at the top of the plant, there's that little turnaround that's inside.
Yeah, this can be closed like this.
But this is-
No, this remains. Yeah, that's okay. As long as this portion, the portion that's inside the vegetation remains, then you're not killing it.
it's
So
making a-
yes, yeah. I'm thinking maybe what we
I
should
see,
do,
okay.
maybe what we should do is for this to wrap around like this. And that makes sure this is, and then there is a 1105. And then you have higher elevation there. So 1105 would wrap around like that to form that berm. And this one is also close to 1105. So once you specify the distances between this one and that one, having another 1105 going around, basically we just removed this portion and remove this portion and asked it to go around it. Does that make sense? You don't have 2, you have 1. You have 1, and then this one would be closed on its own, like that. So you would have, well, yeah, you have to, you kind of have to do it because we can see that the distance here is getting too large. If we do something like this, you can see this area. Well, okay, if we create, oh, let me erase this altogether. If we create a big cell inside here, then it doesn't matter. Basically, this one goes around like that. Does that make sense? So then we actually can move this one over a little bit. That's your 105. 105 would go around like that. There's one on 1105, and then there's 1104 doing that.
I'm still a little confused what's happening.
This one,
Yeah.
yeah, well, just to check if this, I don't know if your 1105, where should it go to make sure that this slope is above 2%? Yeah, if we can specify the location, we could wrap it around up a little bit and then do this. So just this portion of 1105 would need to get precise in terms of where it is. I don't think there's a problem with this portion because it does definitely seems like here is higher than 105. We're going down like this. Yeah, and we just need to make sure this portion is high enough. And here is mostly going to be above 105. So you won't have a 105 over here unless you make this very steep, this portion very steep. But yeah, yes, yeah, yeah, sure. That's right. That's what I'm trying to say. You only need a 105 wrapping around on the higher side, and then a 104 that's lower as a close contouring side here. So that's what I'm trying to say, that we need to know where this is as 105, and then we can connect it back here, and then it can wrap around to make sure that there's a higher side for the 104 here, and you will have only one close contour of 1104.
If this is 106 here.
Yeah.
And my
That's right. So
maybe
right. That's right. Yeah, you're correct. Yeah. Well, my bad. Oh, this one needs to go up here and wrap around. Oh. Yeah, this one just need to make sure that we cover the portion of 106 over here. Yes. Okay. Yeah, and this one does need an RDI because that's the end of the cell. And we want to make sure, the last thing we want to make sure is that your swell goes into there. Yeah. Okay. We'll clear that. Keep going. All right. Kyle, I know your Thursday's group, right? So we'll do that at the end. Yeah, yeah. I think we'll be fine. Yeah. All right. So LPS and LP at the same time. The LPS are my central lines. That's a good question. My RDI in the right spot. How do the it's my fire retention here correct? Is my fire retention here correct? Okay. So this is I'm looking for a number here. 202, that is Keith, right?
Yes.
Okay, good. Glad to hear your voice.
I will.
Clear and loud here in the lab, which is great. Okay, let's talk about this one first. For this one is a very common question. We don't need an RPS, so that's good news. We need this, the spot here at the edge of the pavement. Basically, your swell ends here and it's not an LPS. So we'll just need to put a plus sign and a spot elevation here, and that's it. And your RDI is in a good location. You have to calculate this one, the one that I just marked, which is probably 1105.6 or something, or 7. And then that's the elevation that you are going to use as one of the high elevations on the bank. So I think you're probably a little too low here, 5.6 or no, if we say it's 6. Then your RDI your RDI is a little too high for that reason. but no, until we know the elevation here, we won't be able to specify that one. This one needs to be lower than the whatever this elevation is. Does that make sense? Because you're going down along, sort of this is the edge of the pavement, for instance. It feels like you have a 1105 right here, feels like a vertical bank here that you're creating, which I advise against. There's no curb, but it feels like you having a 1105 hit right here, you are creating a wall of some sort at the edge of the pavement over here. I think it will be better if you create a gentle slope and then the cell. So right now your RDI, it's shown as higher. Oh, if my my raised drop inlet is here, and this elevation here is 1105.6 as I estimated just now here. Your RDI is at 1105.8, then water will not get into the RDI at all. Does that make sense? Because that's higher than what you have on the edge of the pavement over here. And now your LP is 104.50, means there is 2 foot difference, almost 2, oh no, 1 foot difference. So that's good. So LP makes sense, RDI is too high. And I would recommend closing your contour off like this so that you have a 1106 does, you have another 1106 because of the need to have a berm. I can kind of understand that. Yes, you would have, but your 106 would not. Okay, your 1106 actually would not hit the edge of the pavement here, because all the edge here is lower than 1106, right? So your 106 would not hit it here, and instead it will go around. Unless we're not creating a berm here. Let me try to clear here and then look at, zoom out again, see the bigger map and see where your 106 would be. 07, 06. This is 105.6. 5 is gone. Yeah, 5 kind of get lost. That's the plaza. This is what we're trying to create. 1104.5. The edge of the pavement is 1105.6. And your RDI needs to be at the same 1105.6 here. And then we'll keep going down at 105 here. So you're trying to create a berm, which is something like this. I'm exaggerating, okay? So yes, you would have a 1106, but the 1106 is going to be at the same elevation here instead. So your 1106 would not be hitting the edge of the pavement over here. So we'll need to find out where. What I'm thinking is that you actually don't need to specify the HP to be higher than 106. I think that probably makes more sense.
So how do I know if there's a berm right there?
You could say, let me 105.6. 106 here. You could say this is 105.9. What I'm trying to say is if you want to create a 1106 for your high, well, your high point definitely don't need to be 106.50 because that's 1 foot above the edge. So what we're trying to create is some sort of this scenario. Let's see.
Maybe I could remove that 106 contour and
That's what you're trying to create.
mhm,
If you
mhm,
want, let's see, HP here. That's a possibility.
mhm,
So then that does not need to go up to 1106. Then you would have another 1105 in terms of contour. So this is 06, 05 is over here. That's a closed one, right? I
mhm,
don't want to use that color. 05 is going to be here. That's a closed one. And then there's another 05 going out on the other side. There's a
mhm,
closed 105 and your 105 here basically goes like this.
mhm,
Then your HP, you could specify the HP over here to be lower than 106 to avoid having to create a 106 again.
mhm.
It's not
Oh,
that we can do it. We could. We just need to close. We just need to close this one, doing this, and then having another 6 going around, and then
mhm.
having another 5. But I don't think that's necessary. So that's why I think having this at a 1105.9 would actually be the same results.
Okay, I think I'll do that one.
Okay, cool. So let me clear here. Next one is, oh, area. There's multiple ways of doing it. You could, because your, this drains that way. So you could have a scupper coming down and then you could have trench drains that goes this way. And then you could have your retention area over here,
Mhm,
right? Or you could cut holes in there in areas where you don't intend to use your plaza. So those become holes and depressions in the plaza itself. And you just need to identify a way. Normally, your downspout will be at the corner of your building. So these are determined by you wherever you want to have downspouts.
mhm.
And you just need to indicate how it gets into here.
Okay.
Yeah,
That
you
makes
can
sense.
also take aesthetics into account. So basically you can do something like this instead of, or a crazy pattern in the backyard, your choice. As long as we know how water gets in there, then
Mhm.
that's okay. Yeah. Okay, so that, yeah. You can. You can. That's called a planter. Yeah, but those tend to be vertical and they tend to be lined because you can't directly infiltrate. So it's mostly for, I would say it's more suitable for a highly ultra urban area where you don't have areas to infiltrate because it's close to building foundation. You cannot directly infiltrate there. So if you have, for instance, a very old roof, when it breaks down, it releases pollutants, then because it's lined, it's mostly for water quality instead of water quantity. So that's where I would advocate for those type of applications. When we have room, I would not put it right against the building wall. Yeah, because it doesn't really reduce your quantity that way. Okay. So that's that. Moving ahead. It depends. If the question of combining depends how big it gets, right? If its drainage area gets above 5,000 square feet, and then definitely no. Because once the drainage area gets that big, you end up with channelization in the very least, because you now concentrated enough water to create erosive flows in the cell. So it's hard to evenly distribute the water to amplify its infiltration functionality, okay? So if the bioretention is as small as the one at my car drop off, can I grade it without berms and just rely on the curves? How do I approach that? So right now, yes, that's correct. Yes, because this is small, you would actually have retaining wall along the lower end of the cell. Yeah, and that well, short retaining walls. So those are deep. Those are curves that extend deeper into the ground. So it wouldn't necessarily be a half-foot high. Yeah, definitely. I think that's a really good question. All right. Do you mean how do you grade that one? So the key thing is to figure out the lowest elevation along, which is along the swell line. So you need to figure out this elevation here, so that you can build a cross section, right, where water enters, and so that elevation is where water enters, right? And then you need to figure out this elevation on the kind of the bottom of the curve. Then you would have sort of this situation, and then you use that, the bottom, the top of the curve elevation, determine where your water level is. The water level would be like this, right?
Yes.
So that's, again, this is a wall that extends lower. And then you could design this for this to be a vertical wall, but I would say it doesn't look really good if you have a circle with vertical walls like that. So if you can have some side slope that's sort of doing this, then I would probably advocate for at least one part of that being a side slope. But here you would know that water drops in, and I would need some type of cobbles, pebbles, or rocks to dissipate that energy for it to come in. Okay. And then this one you do need, okay, you don't really need an RDI, but let's see. When it fills up, how did it get out? No, it doesn't really. So this one is an RDI. Yes, it does need an RDI. So let's put somewhere here an RDI. The elevation will be informed by the water level that you determine. Okay. But the key thing is to figure out the bottom of curve, top of curve elevation for these two spots that I labeled as red. Okay. Moving forward. Can I put a DI here instead of a trench drain going to the bioretention area? Here, the DI also needs to go somewhere, right? The
Oh,
DI, yes, the DI would have a pipe that connects to another bioretention layer, which I don't think is a big issue here.
mm,
So basically it means that you would have a pipe. Yes, you would have a pipe that goes somewhere here.
do I just show it as a line going through there?
You don't need to show it. You don't need,
Mhm,
you can show it as a dashed line,
mhm,
But honestly, I think it might not be hard. It actually might not be hard to even cut down the pavement like that.
So
The
there's,
reason being,
mhm,
you do not want people to get off where there could possibly be ponding water.
mhm,
We always want to assume that DI at some point will be blocked.
mhm,
So I think you don't necessarily need a lot of pavement over here.
mhm.
Then this can directly go out to a cell that is over here.
Okay.
So you would have two. This one is dirtier. That one is
Mhm,
cleaner. I
mhm,
wouldn't advocate for mixing those because this one is significantly dirtier
mhm.
and that one is from the plaza, right? So I think that's a better solution than having to put a pipe or having to have a trench drain.
Um, so um, I have another bioretention area next to it, next to the area you encircled. Can I combine those?
Yeah,
Like,
you
okay.
could. You could. The reason being the two curb cut is not very different in its elevation, or it's not too different. So this is not significantly higher than that one.
Okay, so okay,
Yeah,
so I can still combine.
yeah, they can be combined.
Mhm,
Yes. All right. Okay. So this one, we have a curb cut over here, 1107.9, which I don't think it's correct though.
mhm,
No, that one should be lower than 1107.9. 1107.9 on the plaza should be somewhere here.
mhm,
This is calculated by this distance. So I would say this is close to 1107.6.
mhm.
That's probably more accurate. Because of that, yeah, your LP will change to lower, at least
Mhm.
0.3 lower. And then your HP, yes, you would have a 108 and an HP. That's correct. So overall, except for the CC,
Mhm.
other things are correct.
Okay.
Okay.
Okay. Is it possible that I could just move the curb cut higher so that it's also 1107.9?
You could, but you would miss some opportunity to receive more water.
Oh, okay. Right. That's true.
Yeah. You could even move it a little bit lower though,
Mhm,
to the point where it couldn't, but it doesn't make a huge difference.
mhm.
Yeah, but if you put it here, then you're only dealing with that much water.
That's okay. That
Yeah,
makes sense.
yeah, yeah. Okay, so that's that one. Let's take a look at here. We have water is not getting into the cell from this direction. So
Mhm.
your curb cut is actually going to be here. Oh, okay. So if I zoom out, then I see that's not the case either. This
Mhm.
whole thing is on the ridge. So you don't actually have any water unless you have a trench drain of some, well, the trench drain that what is this dashed line here?
Dash.
Is this a leftover thing?
Um, I
This, oh,
can't.
those are okay. I see. Those are wheel stoppers.
Yes.
Yeah, your water is actually not, you only have this small area
Mhm,
that goes into your big cell. That's
mhm,
the only the only treatment that you can get, which still, which still, warrants something in there. Okay, let's see. You have a 1110.9. That curb cut again. The elevation needs to be calculated based on the distances.
mhm.
I'm going to say this is about 110.7. And based on that, you can adjust the numbers over here.
Mhm.
But this, you only need a very small bioretention here because you don't have a big drainage area there.
Mhm.
Yeah, ideally, you would have contours like this, but at this point, I'm not advocating for changes because you also have, I think you have pretty flat area on the north side. Yeah, this is pretty flat. You still will be able to fit in a lot of bioretention over there. So I'm
Mhm.
not too concerned. Okay,
Okay. I think that's it
all right.
for my. Thank you, Wuhong. That was very
Oh,
helpful.
you're welcome. Let me zoom out just to make sure. Yeah,
Mhm.
cool. Moving forward. Field 3. That's Sam. Okay. Making sure you're here. Okay, good. Great. Let's see. So that will be cut down there. So you wouldn't have the middle part there. Between the north corner of the building and the drop, I'm struggling to reserve 1105 and 1106. And then, okay, let's zoom into that area. Oh, 05 is over here. Your original 106 is over here. Yeah, I have I think it's probably somewhere over. Let me start over. That's where your original 106 is. The spacing still seems a little off to me. So maybe it's actually like this. I don't, why is that? Let me try again. Yeah, I think there's a spacing issue about the original 106.
Hey,
Uh,
so those contours are spaced, I think it's like 50 feet apart between, so on that bus drop off.
mhm.
So yeah, it like pushes, yeah, it's confusing me because it pushes it off the pavement entirely.
Yeah. Yeah, let's go back. Let me zoom out a little bit so that I can see where 1106 originally is.
Okay.
So when we get a little confused, you probably have a pretty complicated situation before.
Well, in all reality, it probably 1106 is probably not even relevant. Like it probably just gets entirely graded off for this site, I think.
I think that's the reason
Yeah.
why. So now what we have
Right.
1106 is actually this.
Yeah, uphill. Yep. Yeah. So yeah, it's probably not applicable here, except for it does exist on the patio. Do you think it gets deleted on the plaza?
Should be like this, but I'm trying to find another 1106 to go back.
Okay.
Yeah, that's. I'm also a little confused, so let me try to spend a little bit of time figuring this out. Okay, so that is where it was. Ah. And what remains is this remain, that remain, this goes like this, goes back over here. This portion remain, that remains, that's looking very thick. That's going to be like this. And then it goes down here, there, there, and there. That's your 106. Now your 5 goes like that. I am not good. Yeah, wrong. Now it needs to go here, go there, and go here, go there.
Oh, really?
Let me go back a little bit to
Okay.
be parallel. So
Hmm.
that's your 5. Now you have to close the other 5. That's correct.
Okay. Yeah.
And this will be lower than 5. You'll have another closed 5 to create that retention area.
Okay. Yep.
Yeah, I'm gonna save a screenshot just in case you need it later, but
Yes.
this is basically your 6 and 5.
Okay. Thank you.
Okay. And let's close it up. Zoom. Zoom to, should there be a DI? Yeah, a DI needs to be somewhere over here.
Okay. Put it in the corner there. Catch all
Yes.
the water that drains down. All right.
Right. And let's move down. Part 2 with the trench drain running from the parking lot car sidewalk. In your situation, okay, let's zoom in. Let's see. Let's find the lowest elevation first. So how do you find the lowest elevation in order to find out where you should have that trench? Do this, blue. So basically you want to find out, use this, find out the lowest point, which would be somewhere here. That's your lowest point.
Okay.
Because this point has the largest distance to the next contour, right? This is where you have your trench drain. And then that goes across to here. And this one is it's the same example as I showed Jonathan, where you would have your your BC is actually your top of the trench drain. Does that make sense?
Yeah.
Yeah, and then so you just need to build in that the height of the depth of the trench drain to know where water start to enter the bioretention here at what elevation, right? And is this mainly regard to how to represent it?
Yeah, I was a little confused because in watching the lecture videos, there's an example of a trench drain going through like a little bit of a sidewalk space like that directly into, and in that example, like the wording, it kind of confused me because there it said like curb cut and then it goes straight into a trench drain. And then in other examples, it's like just a trench drain straight from the curb. And I'm wondering if, yeah, what the proper thing is. Like in this situation, should I just have a trench drain? And just it's implied that there's just like a hole in the side of the curb and it drains through, or should I represent?
Yeah, this one is a little different from what Jonathan has. I'm sorry, misspoke about that. So this one, your trench drain would actually be, let me draw it out. So this is going down. That's your curb. And this is where, this is the curb. That's the curb. There's no curb over on this side anymore. So this is the parking. And this is the bottom of that's the bottom of the trench. The bottom of the trench. This is where people walk. And now, because the plaza doesn't have a curb, it actually just goes down like that. So on this side, you would have the bottom of the curb. Actually, that's your bottom. That's the same as the bottom of the trench drain. Does that make sense? It's a little, it's different from where Jonathan has to cross another parking lot
Okay, yeah.
because water cannot run. The trench drain cannot run. Now the trench is here for yours, but for his, it cannot run on a raised at the same elevation as the curb. Don't know if that makes sense.
Yeah, that
yes.
makes sense.
Yeah, so your parking lot is going like that.
Yep.
And basically this is the trench going down.
Yeah.
And this is where it comes out. So you would say let's see. Right. Yeah, here you would indicate a BC/BTD. Then here you calculate the BTD here, and that is the elevation water enters the cell here.
Okay. Yeah, I guess that answers my question there. I have another dumb question. I'm sure it's written somewhere, but would you know it off the top of your head? What percent grade should a trench drain be running at? And I'm sure it's covered
1.5.
1.5.
Yeah.
Okay.
Yeah,
Thank you.
1.5 will make it sufficient because it's more reliable. It's more reliable than when we grade a paved surface. We always wanted to have 2% for a paved surface. 1.5 would make it sufficient to drain, but to build in extra safety kind of cushion in case the pavement breakdown or it wasn't built well enough, we wanted to make it 2. But a trench drain, because is very specified, kind of the materials and everything, so you can use 1.5. If you wanted to use 2%, that's totally fine too.
Okay.
Okay. Okay, that's about, is that all the questions?
Well, could you take a quick look at my my back of the building area?
Okay.
And for this final submission, it in the fine print is saying like 3 bioretention areas, but should we just make bioretention for everything, including the top of the building?
I think you could do 3 if you haven't been reviewed in terms of the correctness of a bioretention, then it's safer to do 3.
Okay.
Yeah, but if you're very confident that you get it down, you it wouldn't require you to redo everything, then you can move forward of working out all the rest of the bioretention.
But safer to do 3 and get them.
Yes, get them reviewed to make sure they're correct.
Okay. Can you take a closer look at my bioretention areas to see if I'm on the right track with them?
Yes. Yeah.
Okay.
Well, so this one, I wouldn't think is that necessary to put in a wall here.
Okay.
You would have a wall. You would have a wall here and there that I think it's probably going well. That this one is also open for question.
Okay.
But it's not just, if we can direct the water away from the ramp like this, we'll choose to do that instead of directing it that way, right?
Okay.
And if we have 101 here, you can see we can still attach. Oh, okay. That is not, this one, 101 here is not correct. And we would want to have 101 just like that, right? 1100 can do this, and that can keep going. So you don't need a wall there. Then I'm looking for the, so that's, yeah, it's probably over here.
Yeah, I just put that that retention wall in, thinking if I put in a wall and just raise that that ramp up a bit, then it would save on running those contours down to the property line.
Oh, so property line is over here, so I'm not
Yeah.
too concerned about that. Yes, I
Okay.
think you can directly connect back, and it's actually better for water drainage away from the building. Otherwise, you have everything honestly draining along the wall here,
Okay.
along the edge of the ramp here. And you see we're creating a
Yeah.
swell here,
Yeah.
and all the water is going to get in here. And I'd rather everything kind of just dissipates. Well, for this one, some of them will have to, get down to this area, and we'll put a DI somewhere in this
Okay.
along this route. But otherwise, you wouldn't need any other things to direct a large amount of water away. So we have a 1096. I think you can have your 1106 somewhere here. Yeah, your 10, then this is 95, right? So this can go back to existing grade. Your wall would be like this. And the other, I'm not sure about. Okay, let's take a look at the contours here. We have, we're starting with, this is 5. Is that 5 here?
Let me double
Yeah.
check that. Okay.
I think this is 5. Yes, this is 5.
Yes.
4.
Yep.
3, 2, 1, 0. Yeah, okay. Now I see 9, 8. Okay, let me go back. 0, 9, 8, 7. This is 7. And we need to get down to 6 at this point. I would actually suggest that you move the whole thing. You move this down.
Okay.
Down where we can get close to the 6 contour here.
Okay. Yeah. Okay.
Then
Move
you
ramp.
wouldn't have one contour that goes like that, right? Goes along like this. I think moving it down so that we aim for this type of relationship will be easier for you.
Okay.
Yeah. And you get a more spacious connection over here. You can even turn it so that if you don't want that space, you can turn it. But we're trying to aim for a good connection of the 96 contour with this 96 contour. Okay, so that's the ramp. And let's take a look at one of the retention area. Maybe this one?
Yeah.
That one may be one of the complicated ones because it's on the plaza. And we honestly have just determined that this goes like this. Somewhere like that. That's your 106. So your entry, your water entry is somewhere over here. We want to try to figure out the elevation there, I would say that's about 1105.5. And if your RDI is at 1105.3, that's good. The LP 1104.3, that's great. But we do need, we need a retaining, a short wall along the side to be able to stop water from spilling out, right? So we don't have a curb here. Again, I would encourage you to do a cross section. Not in blue. A cross section where we can see this blue corresponding to that elevation. And then that will help you decide how high the wall here needs to be on the other end. Does that make sense?
Yeah.
Yeah,
Can I
yeah.
keep it simple and just make like a wraparound, maybe 18-inch sitting wall or something there?
Yes, yes.
Okay.
Yeah, yeah. So wrap around, that means this is a cut, right? I don't think you would have the whole thing wrapped around because people still need to walk.
Yeah.
So you would want to leave, I think your wall will be along this end. Your wall will be along this end because you want to leave people walking distance here.
Yeah.
So no, they would be sitting somewhere in this area.
Okay. Yep.
Okay. So the RDI looks good. The LP looks good. The wall needs some work. Let's see if the TD and everything works well here.
Well, hey, I have another question about the wall. So for a swale like this, for labeling, would you, this is a silly one, but would you mark the top of the wall as HP?
No, you wouldn't.
No.
Yeah, you can
Okay.
directly use B wall and T wall.
Okay, cool.
Yeah, you just need to make sure that now here the elevation also, because the B wall would be low higher here than there, right? So there is a point of determining how much the wall needs to be wrapped around to be able to prevent the water from spilling over.
Okay.
So if you make it long enough, it definitely won't be a problem. But in case there's a short, it's a short wall.
Yeah.
Well, if you make it entirely 18 inches, I think it's going to be okay. That'll be okay.
Okay.
A reminder that this does not need to be rounded. This corner would not be rounded because that's part of the parking space.
Okay.
This corner will need to be rounded, right? So those are actually the right angle.
Does that curb where it needs to be rounded, does that need to be rounded at a more extreme radius?
This one, yes.
Okay.
Yeah. Here, you can use 5. When it gets to driving aisle, use 10.
Okay, thank you.
Okay. So you check one more thing. Oh, okay. After looking at this area, I would actually suggest that you don't have a trench drain that goes this way, because again, this is dirty water. This is clean water, right?
Okay.
Oh. Inevitably, I think, okay, inevitably, it's going to be dirty water mixed together because that's the lowest point. So again, your trench drain will start here because there's no way for you to treat that water besides getting it into the cell. So this is definitely mixed. But notice the surface entrance elevation is different from your bottom of the curb entrance. So that's your entrance. That's much lower than the surface elevation that we determined here. So this will be much deeper than you think. Okay. So
Okay.
this is not just treating for plaza water. And in that case, would it be possible actually to make some changes and say, I want this to be walking space, and the whole thing here is a garden?
Okay.
Because upstream here is not receiving a lot of water from the plaza anyway, and you would rely on this to treat the most of the plaza water. So I think this is a little bit better solution than having trench drain from both sides and this becoming a very deep thing.
Okay. Yeah, so change the shape of the plaza and spread out the size of it and
Yeah,
just and fill it with curb cuts, or should I incorporate trench drain somehow?
curb cuts will be good.
Okay.
Would be enough. You don't need
Alright.
trench drain anymore. So if we say this is where people will walk up, that's where people will walk up. Let me erase that one and use a blue. I think this will be much better. Because now you have two water entrance from relatively the same elevation. Water comes in here, water comes in there. Those two are roughly at the same elevation, right? And then this whole thing over here would be dealing with the plaza water.
Okay.
Okay.
So for the big one draining from the parking lot, should I do like berm it on the side of the plaza to make sure that it's not well, no, that doesn't make sense.
You won't need the berm anymore
Okay.
because this is higher. This is
Yeah.
higher elevation on top of the curb.
Okay.
Yeah.
Okay. Let me think. Yeah, thank you. Is there any issue with putting a curb cut in a corner like that, or that's
That would be no
Okay.
no problem.
okay? With the ADA parking, should I maybe allocate more space for getting outside of the car so they don't fall in
Oh, yeah,
the
that's one of the issue there.
Hmm.
Okay, so let me clear and see if we can. Yeah, all of your ADA is actually at a location where there's possibly ponding water.
Hmm.
Yeah, that's hard. Because with the ADA parking, you actually need, I didn't see that one. You actually need sidewalk. So when the entrance is over here, so you would want to probably leave that much space while walking. But if we have something, yeah, that's tough. Yeah, we kind of have to make a decision of what we want to sacrifice. Is it ADA moving to another location? Or What
Would
we
that
can-
be the simplest solution, is just shift those ADA spots over a space or two?
Yeah, if we say, if we want to do something like that, and, oh, okay, then we will need something in the middle that people can walk on, then maybe there's a ramp, a raised walkway over to the side.
Mm.
So if you still have if you still have some room to make this shorter, I think this can be a walkway.
Okay,
And then you have ADA over here,
okay,
and then people can walk up, and you can have a elevated walkway from this, from this all the way to the building. That's some extra grading that you need to do though. For this one, if we want to put ADA here, you would want a walkway as well going up here. So how about if we have ADA walking over here, and then that's where you would have that walkway.
okay.
I think that's a walk around. This is not too hard to do for this area. You need one trench drain going through here,
Yeah,
and otherwise, no, this one is already done. Well, the lowest point, again, the lowest point is somewhere over here. And then I think that's a, yeah, to put ADA a little bit far away, that's not a perfect solution. Is there any other better solution? We need walkway.
could I do something like with that example from Portland where there's a curb cut and it extends through the sidewalk and there's
Yes.
just a steel grate on it?
Yes, that's again a trench drain solution.
Oh, okay, all right.
Yeah.
Yeah.
The issue is that we need all these connections. That one, this one is pretty far away. Let me try to move that on over. Yeah, that's where it needs to happen.
Okay.
So all these connections goes into the middle. That one only requires one. When people drive over here, they see this first, so that's a pro. Okay, I'm gonna opt for this solution.
Okay.
Ideally, people would want to park over here, and you could add a walkway over here. That's not a really hard thing to do. If you want to try that one, I would encourage you to do that. So if I can have an elevated walkway here, then I wouldn't feel bad at all for putting ADA over here.
Okay.
If I want to put ADA over here, I would add this one, but this does look like it's a compromise solution.
Okay.
And because all these connections necessary, I would say, if I want to treat the water, I would do this.
Okay.
Yeah. And to put a sidewalk on top of this, again, it will look like a compromise solution. But let's see. Yeah, it adds too much complexity in terms of what the wall would look like, and well, so okay, let's opt for doing one of these bottom solutions.
Okay.
Okay.
With putting a oh, I have to look at the fine print. How many ADA spots do we need?
Is it two? It's only two.
Oh, okay.
So it's
All
only
right.
3 parking space, regular parking spaces.
Okay. Yeah. All right.
Okay.
Sweet. Thank you.
All right, I'll move forward then. 111. I think this is Layla. Is that right?
Yeah, that's me.
Okay. Let's take a look at, do my HP and LP and RDI for the retention area look correct? Well, first thing I would say is that we need more space over here. We can start to see that all these contours are too close together. So what we need to do, 11013 is over here, would be, dragging it up here. And then 1102 would do something like this, because we still need to leave some area in between for retention, right? So all these contours needs to move over to the north side so that your slopes wouldn't be too steep, okay? And if we look closer into what these areas, so you have a curb cut at 1111.95. I think the calculation is off. Again, the calculation is to be based on the distance. Okay, so the curb cut is at the BC level, bottom of the curb level. So this is close to 1111.2.
Yeah, I don't know what I was thinking there. I totally messed that up.
Yeah, this is 1111.2. And then based on that, we can adjust the LP. LP would be 1110.2, right? Because you want to keep it 1 foot difference. So LP would be 1110.2. Then you would have another 1111, yes, and HP would be 1111.5. Those look okay to me. You don't need an RDI here because water will keep flowing down. So that's this one.
Okay.
Let me zoom out. Your DI would be wherever there is a dead corner. So locations like this one, if you don't have a DI, water will be ponding there. So those are the locations for the DIs. And for the RDIs where you don't have another cell downstream. So places like this one would have an RDI. Another other locations of DI, let's see if you have dead corners. No, you would need one over here, the lowest point where water has to come out. Yeah, and you'd also need a cut somewhere over here because the water comes down to the curb cut and it doesn't have anywhere to go, right? Oh, this one would still keep flowing down that way, so that's okay. That's okay. That's the ridge line. It goes down there, it goes, this location is keep flowing down. Okay, so that's okay. That one needs DI. This needs some curb cuts. Here, the lowest point needs some cut. And yeah, that's probably it. The curb cut here wouldn't be able to receive any water. You need to have 2 of them. Well, not any, like very small amount of water. So this will be, if curb cuts are in those locations, it's only that much of water that's getting into your retention. So I would recommend removing the curb cuts downhill at locations like this. Okay.
So I do 2 curb cuts there, and then would I do 2 like
So the
Like
other one would
berms or
be,
no?
yeah, the other one would be somewhere here.
Okay,
So that's your area of treatment.
okay. And I know I have to, same thing that you said on the other side, bring these contours out, and I gotta fix all my high point and low points here, but I know how to do that now.
I'd say your contours needs a lot of work.
Okay.
The spacing, being parallel to each other, 50 feet, right? And the area here, trying to create a conversion or divergence swell. And some of the contours being cut off over here, like the 1113 needs to be closed off and turning on the vegetation layer so that you know where you need to stop, kind of changing the contours. So I would do a check first on all the parking lot contour to make sure all my spacing is correct, like these ones, right? That one, no, 1108 wouldn't be there because your spacing is off there. And then I would move out to, using these connection points, move out to this area because the spacing remains problematic. And then I'll come back to this area for the divergence swell. And then once I have an idea of where my curve cuts are, I know where to create some retention areas. And then that will help me decide whether or not these contours like here needs to be changed. So I think there's quite a bit of work to do for your contours. And if we have time, you should try to get an additional review on Thursday.
Okay, thank
Yeah.
you.
Okay. So 112, that would be Parker.
Hello.
Hey, how are you?
Good. How are you?
Good.
Good.
Are the locations for both parking lot drainage areas effective? And here we have, is this the correct depth for the retaining area? Would this shape positioning of the drainage area work? So I'm seeing a very small swell line here. And Parker, to be honest, I'm a little concerned about the angle of your the parking lot contours. Because overall your swale is not going into the middle of your retention area. Your swale is going this way, very close to your building. And there's overall a pretty small side slope that the small side slope, meaning that this is almost perpendicular, not perpendicular to your driveway, meaning that we're not effectively directing water to the side for collection. Yeah, I'm hesitant to ask you to try to change the angles of your parking lot contours at this point. But
Okay.
I'm also seeing the issue that might be caused by that.
Okay.
Well, this swell line very close to building thing. I'm afraid I probably need to ask you to change that. So let's see how many space you have to, okay, let's pull the building back. Once we pull the building back, the swell center line would not be too close to your building. And what can we do to this area? You would have a swell center line going along here, meaning that you have water concentrated and you need to make holes here, and there's not a lot of flat space. Okay, so that likely, let me try to think what's the best strategy here.
Okay.
Okay, we have if we pull it back, if the building line is over here, then what we could do is that we keep that, and then what if we do this?
Just change the angle of the upper part.
Right, but how can I direct water actually in there? It feels like at least I have to change it like this to be able to do that. So that's yeah, at least this will go through, and then it end up with going into pretty flat area. So that's a little bit better. If I change it like this, how much damage am I doing? There's a 3% slope over here all the way down. I'm fine with that 3% slope. 12. I don't, well, so Parker, I don't necessarily think 3% is necessary, because you can see you are at 12 here.
Yeah.
This is pretty flat. What I meant was, so you have room to make it flatter and make the entry drive steeper. So I don't think it's necessary to make it 3%, but again, I leave it to you to decide. It's an acceptable slope. But
Okay.
you know, yeah. Then if we do something like that, well, if we choose to do that, we might as well just angle it, because it will make your drainage much easier. So if we keep the spacing, yeah, this is actually working better in terms of directing that water into this flatter area.
Mm.
I wouldn't put it right here in front of your, well, depending on how big spacing here is, 10 feet, well, 10 feet will be okay. So yes, you can have a retention area at the end of the plaza, but you can also say, my retention area is downstream here.
Okay.
So if that's the case, we're basically in this situation. Let's see if the number will change much. So if we keep this as a 6, is this a 6 or 7? Your parking.
Is what, 6 or 7?
Oh, this is a 4. That's not correct. If you have a 4 contour here, your top of the feet would not be 6. So let's say this is 6, 7, 8, 9, 10. Then our next question is how to get from 13. If that's the case, we can make that 11, this 10, that's 9, that's 8, that's 7, and this becomes a 7.5 for your building. Now, this is 11, and that is 13, and I think we would be able to make it work by having another 12 in between. You could angle that once it gets in. So I'm just gonna delete this one. You basically have a transition there for your 11, which is okay.
Okay.
That's your 11. So, all right. So that all gets into here. And you have a curve also around here. Yeah, that's your green area, right? Which is great. This is great, having something in the middle that is big enough, no, on the lower
That
side.
not all of that. I had that my plaza extending down into that area. So the plaza area stops at where
Oh, here, yes, okay.
a little bit
That's
further
okay.
than that actually.
So basically, if this is the area, then that's too small.
Okay.
And I would say, let's do this.
Okay. Okay.
Well, if you want to have a walkway on top of this, that's okay too. But I would not remove that one because this is very critical.
Yeah, that's what I
Most of the area here drains into this, and that's not big enough, and it has to
Okay.
go somewhere, right? Now, if this is the lowest point, and this is not green area, you'd need a pipe of some sort to go pipe it into here or there. Both are too far away. So let's
Okay.
keep this one.
Okay.
And if you want a walkway again, I think we can. Oh, I probably starting from here. Yeah, maybe that's the way to go. Okay, so you
Okay.
can have a walkway somewhere like this and getting to the plaza area, the area there. I would
Okay.
still advocate for, so if there is a, it will keep flowing down. There is a dead end over here. If there's a way you can create a hole somewhere here, will be beneficial because then that can go down here. You can see that there's a dead end here, right?
Yes.
Without anything, you'd need a DI over here. And that's a fair amount of water actually. This will keep going down that way.
So are you saying put a DI in that bottom right corner of the parking lot, or are you saying put like a
Yeah.
retention area in the plaza space?
You need a curb cut along with DIs that connect to a retention area somewhere close by.
Understood.
Yeah. And honestly, this area feels like a good place for that.
Okay.
And you could move or extend it somewhere here. I think that that works too.
Okay.
But this dead end needs some treatment.
Understood.
Okay, so now our swell, okay, our swell is going down there. You have something in the middle and at the end that works. Now that your water does not go to the side, you don't need as much area, flat area in here. You can tie them pretty close back to that area. So you don't need to move these contours far to the north to connect
Okay.
back. Okay. 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 Those are good. And somewhere here you need a curb cut to go a trench drain of some sort. I wouldn't advocate for this sidewalk. I think if we specify people have to get off on this side is easier. This is a small building. You wouldn't envision that many cars or buses have to line up here for people to get off. So I think it's okay to say, this is where you get off. And then having a connection to the ramp here. Basically your pavement can stop here. And then that's where people get off.
Okay.
Now you would have a bigger space here for retention, and you don't have to create two. And then, okay, so those are some of the contours, contour revisions that I would recommend at this point. Let's see. Okay, let me clear and look into some of the retention area, okay?
Sounds good.
So as we talked about before, just assume that we're using your original contours. Your curb cut here will be determined by, so this is 4. So your, I don't know if your contour connection, this is lower actually. Okay, so it's probably backwards. Let me double check. Your 5 actually goes this way, right? That's your 5. That's your 5.
Not in the way that it's drawn, but okay.
That's the 5. So this is 4. So that means the curb cut will be 4 point something. Does that make sense? Instead of 5.15, yeah. Again, this would be determined by the distances between here to 5. So that would be 4.15. 4.15, and then your LP will be lower, will be 3.15.
Okay.
Then your HP would be 4.75. Yeah, that's correct. This is correct. And this is 1 foot higher. And you would need an RDI over here. Yes.
Okay.
Well, once you change your design, this actually the situation changes because you have a V-shaped contour like that. So your lowest point is actually here. So your high points is actually on this side.
And the curb cut should be on the south side of it.
The curb cut will be perpendicular to your contours. Right? Our contour, we change the contours to be like that. And your curb cut will be somewhere here and there.
Okay.
Somewhere here in order to capture a lot of water. like that.
Okay.
Okay. Yeah. Okay. Let's take a look at one more thing over here. These are okay. Yeah, if you have these islands, that you're correct that no, an opening needs to be made at the corner. Otherwise, that becomes a dead corner again, right?
Right.
So you have 1, 2, 3, 4, and they're evenly distributed, and they're good. Okay. You would not necessarily have a wall in between, because that prevents for them to be, if those are berms, then that's okay. I don't know what they necessarily represent though. I think it will you have to grade them out and see which contour, how each contour goes around each cell to be able to know whether or not these lines will be in these locations.
Okay.
Now, again, as I mentioned, these are the points of connection of contours that doesn't change, right? So,
Right.
so those are, now if if it ends up being like this, that's okay because it's flexible. If you want to create a cell in here, that's relatively large, but I'm not sure if we need these the double lines over here.
What I think I was trying to do is separate the different retention areas, like
would
just
use
like fully
HP.
from one another.
Yeah, you would use
Okay.
HPs, and if there are walls, you use how you represent walls, BW and TW to label them.
Okay.
Okay. Sounds good. All right. I'm gonna move forward then.
Sounds good.
Here. One, 1, 3. That will be Olivia. Hey, Olivia. Oh, you're not here. So not sure what to do with that. Give me 1 second. I'll return to the main room and then I will check if I should drag on breakout room. Ha. All right, then I'll skip this one. We will have Julia. Cool. Yeah, you're here. Great. So, what did I do? Well, I like busy drawings. Does this sitting wall work here, or do I also need to define HPs in the retention area? Nope, you can use a wall. So not entirely sure that the wall is long enough yet. Okay. Extending it over? Yes, you definitely can. I would recommend doing this. So that's the edge of pavement, right? So doing that and also some rounding on every side would be good. Yes, the wall needs to wrap around. Then Do I need a curb cut on the side of the bioretention? No, this is on the plaza. On the plaza, you wouldn't need a curb. Yes, well, sheet flowing. Yeah. Yeah, I don't think you should separate them because they're at the same elevation. Because your swale, yeah, it feels like you have one on this side and then another on that side, right? Yeah. I think it's okay not to separate them because they are basically at the same elevation. You know, the elevation is like this, and then eventually they all drain out, not drain out, an RDI. Yeah, because of lack of elevation difference, I wouldn't separate them. Right, otherwise you have to create additional berms and things to an additional RDI, and I think it's not necessary to have two RDIs. Yeah, that's okay. Yeah, right, yeah. And your RDI right now, it's 0.4 or 3 below. Okay, that's fine. Yeah, RDI 0.3 below this this entrance elevation here. So that works, and we'll just need to know the bottom here, kind of the elevation over here. That's the lowest point. That's the lowest point. And we'll just use the distance here to calculate what this is, right? Right. So we're sheet flowing, and the entrance here is 1104.9, right? And we want to, that's a bad color. And we want to know what this is. According to my estimation, that might be 1104.5. So this is probably, yeah, well, 104.4. So that's about one curb in difference. If I want my RDI to be 1104.6, which is somewhere over here, and that's actually a blue line. That's my water level. That's my water level at 1104.6. Then I at least want this wall to be a height that you determine, right? So the top of the wall, if this is the ground elevation, and 1.5 feet would be top of wall will be 1106, which is definitely going to be able to stop the water from spilling over. Yeah. 1.5 sitting wall, right? Are you doing a sitting wall or just a wall? A sitting wall would be 1.5 feet high, right? Yes, yeah. So you just add 1.5 over there. And your bottom, yes, above this bottom, above the ground here. Not above the water level, because your feet. Yes, yeah. So the wall here, it's dependent on the ground elevation at 1.5. Yeah. And then your water is 1104.6 and your LP is 1103.6. Yes, so that's where your water is. That's where that's what this would look like. I'm again, the slope it's not correct, but the shape should be. Okay. So I'm gonna clear this. Then move to here. Would it be possible to put a training lot here? You don't have to. Mhm. Yeah. Exactly. Yeah, you don't need a curb cut or an RDI here because water will just keep flowing down along the curves to the lowest point down here, right? So yes, DI here is correct. This is correct, and that is correct. And because this is all going to just keep flowing down, it's not necessary to have any DI or RDI in this cell. The curb cut will just be preventing water from entering. All the excessive water will keep flowing along the curb. Yes, yeah. Right. Yes. Yes. That's right. Yes. Yeah. Okay. The DI is over here. Good. Again, you wouldn't have a curb cut here because that's the edge of the plaza. Yeah. And right. And the other thing is that your curb, well, your edge of the pavement would be, no, I think it might make sense to do something like this. Again, if people are being dropped off over here, that's the relative, the straight portion of the curb, right? Then this will directly come out there. Then you don't need a trench drain, right? Otherwise, yeah. No, at a minimal, you would turn that so you are not dealing with a very acute angle in pavement. Nobody will use that, right? Yeah. So, okay. That's that. Is this HP too close to the 1103.5? I think it's okay, based on 2 feet, right? As long as it's 2 feet away, then you should be. The berm. Yeah. Yeah, the thing that I see here is actually the swell doesn't go inside. The swell goes that way, and it doesn't intersect with this. So basically, this assumes that water will, once it gets off the pavement, it will just, go in different directions. But I think it's better if we make it go where we want it to go. So let me make this a little bit, so that's where it comes off. Okay, let me clear it. Maybe there's a bigger thing that we can. What if we do this? So HP is over here. And if we do this, what does it mean? It means I will have something coming off like this. And then now the thing that I'm not entirely sure of is whether or not the spacing here. Yeah, that's what I'm trying to ask. If this slope, it's still 2%. If I mirror, okay, if I mirror this over, then it will be, right? Yeah, if I mirror it, it will be. So I think what I drew was a little tight, no. So that makes it, that should make it work. If it's entirely symmetrical with the swell line. The other side, if this is 50 feet, because it's entirely symmetrical, this will also be 50 feet, right? It is symmetrical now, but the swell line, I'm trying to make your swell line go into your retention right now. So I turned that swell line. Okay, we changed the center line slope, but we did not change the steepest slope.
So you said.
Mhm. Right, right. Yes. Right. A little concerned about the swell line going this way. It's pretty close to the building and close to where they enter the ramp. Yeah. So we are changing the center line slope, but we're not changing the side slope. That's the steepest slope. We're not changing the blue here. We're not changing. The slope remains. But that slope, this slope changes. So our contour would look like this. Yes, it will be lower than before. No, the center line slope would not be. No, the center line slope. Because you still have a slope, still have a side slope that's stable. That's fine. Yeah. If you remember our grading the final project.
Right, so to comply with that,
Mhm.
make sure.
Yes. Yeah, that's right. So I know we mentioned about this now is it's your plaza edge. And this can be extended like this, right? So yeah, I think this works fine. Now, if I still want this to remain, move it over. That remains, and that remains. This, I don't think that you need to change this part, but this means my center line would actually be a little different from before, which is totally fine. You can also do this, but you don't have to. Let's see. If I do this, I actually have some more room over here. If we don't, if we keep this, it just means that my center line goes around here, and then I change a little bit. Does that make sense? The only change is this portion of the line turns a little bit. Again, yes, yeah. Right, we basically divide this angle into two, and that's where the center line goes. Okay, So that's the change that this will involve. It's not a big thing. Yeah. Okay, cool. All right, I'm gonna clear this. And yeah, this is solved. And that is solved. Okay, cool. Good. Yeah, you'll need some changes later on for the divergence swell here, as you might have seen the third lecture, because you need some more room here. Yes, yes. So don't worry, just don't worry about finalizing this one yet. Yeah, the next step for you is to work on this for the divergence swell. This one. Is this maximum already? $25. We can get a little closer. Yeah, I think we can get a little closer. If you don't have enough space, you could systematically move this by one contour up that distance, that much distance. And then it will require a little bit of change here, but I'm not too concerned. Yeah. Yeah. Yeah, I think this area will be fine. Yeah. Yeah, for one. Yeah, just that much should be okay. Yeah, I'm more thinking just systematically move up a little. I think it's okay to keep the contour numbers as they are. All right, moving forward. Is that okay? Okay, cool. So, yeah, Shenjun, this is yours.
Yeah, I'm
Yeah.
here.
Okay.
And I have a question like on the upper by orientation near the drop off, I feel it's word or yeah, something wrong with
Here?
that. Yeah.
Okay, let's take a look. Well, some of the contours are not correct yet. Ooh. Let's take a look at the parking lot contours. I think some of them are off. So yeah, some of them are off. You can see, for instance, your 106 over here, it would not continue on the parking lot, right? On the plaza. So let me try to figure out where your original ones are. I'm just gonna use a brown. So that's your 06 in before. That's your 06 before. So everything here would actually remain. That remains. And those remains. So basically your 06 goes like this. And then goes like that. That's your 06.
Oh, okay.
And your 07 looks like they're correct. 07 is correct. Use a brown again. This remains. That portion remains. Oh, I should use a red. Now 07 comes out from here. So you would have this. That's your 07. 6 will be a closed contour here. And 7 is on here, and you have another. Where's your other 6? 6 goes over here. Let me choose a brown here. Your 6 is actually off. Huh, that's a little, I am a little confused now. So 7 goes over here. That's the old one. Your 6 is actually somewhere here. We're missing. The other way around. Okay. I don't think your HPS is over there. Your HPS should be over here. So let's. Unless, okay. Let me choose a less damaging solution. Seven needs to be here in that case. That will make it work. Then we will need to do blue like this. Yeah, that works. That works. Okay. So I'm gonna clear this brown and that brown, so it's clear where things go.
Yeah.
This is 6. Yeah. And that's 7. And this is 6 again, off the pavement. That's 6. That's a closed 6. Okay, so those are the contours. Next thing, let me clear that one. You have a 5 over here. 5 is a closed one. 5 should be red. 5 should be closed. Okay, what do we do next? You mentioned you have some questions about this one, right? This one?
Yeah,
Okay.
yeah.
So let me clear and then zoom into that area. Make sure you get a screenshot about the contours here.
Yeah, got it.
Okay, let me clear, go zooming in. And then here. We said this is a closed contour. And we need to figure out what this is. So that will be 1104 point something. So your RDI is too high. Does that make sense?
Yeah.
You don't need a trench drain here. You do not need a trench drain here because, well, let me take that back. You don't need it, but if you don't want water on the ground, put it in. Yeah, so this is good. If you have a trench drain, it won't have any water on the ground. You do not need this trench drain. Water will keep flowing down, and this is where it comes out of the system, right? There's a curb cut over here, and it comes out to the retention in the north. You do not need that either. You do not need that. Well, depends. Okay, if you want that, and if you don't want your plaza water to get out of the to all be dumped into your drop-off area, then yes to the trench run over here. And there's no curb cut over here. It is the sort of the outlet of the trench drain that goes into the retention area over here. But let's come back to this. You would have a curb cut over here, and the curb cut elevation is lower than 1105. It's 4.7. Okay, so this is 1104.7, meaning that your RDI will be the same or slightly below 1104.7. So that's the elevation of that one.
Yeah.
And using that, you adjust your LP 1 foot below the RDI. So that means it's about right. LP is about right. You do not need an LPS. Do not need an LPS because your swell ends at this point. So you only need a spot for this point. Now, in order to have a berm, you would have a 1105 as a close contour, and then have another 1104 inside. Okay?
Yeah.
So that's your 1106. Let me quickly check here. Your 06 goes down here. 05 wrap around. You just need that to be like this. So you have a natural 05 there. You have a 14. So honestly, you don't need another 05 because you have a natural 05 over there. And this is 1104. 6, 5. Yeah, you don't need another berm there. Your 06 goes out here like that. Okay. So that portion is not necessary. All right. That's about this one. Anything else?
Also like the inside the traffic circle, this
Okay.
violation. Yeah.
There's one more inside here.
No, I didn't draw that, but I think there's problem when I want to draw. It's in this big circle near
This one?
Yeah.
Okay, so for this one, your curb cut will be somewhere here and there, right? Because that allows you to intercept water up to that point. That's too much. This one, like this, right? Anything over on the side does not is not useful because no water comes in. And this one, you do not need an RDI because water will keep flowing down to the lowest point over here. Okay, so that one, no, basically that's how you start, by specifying the curb cut elevation at that point, at that point, and then use that to determine LP and other elevations. Does that help?
Yeah, so the two changing is not needed.
Yeah, they're
Because
not
originally I
necessary.
think, yeah, I worried that
You can,
maybe
yeah,
like,
you can keep
Mm.
this one. You can keep this one, but you
Okay.
don't need the other ones.
Okay,
Okay.
thank you.
All right. I'll move forward to the last one. Sorry, Kyle. We'll probably need to talk about yours on Thursday. 117 would be Tegan. Are you here, Tegan? All right. Yeah, you're back today. Let's see. Let's see. Breakout room. Dun, 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 dun. Nope. Okay. All right. Wow. Yay. Do I need more retention basins? Okay, let's definitely take a look at that. May I use the curve as my AP? Yes. Should this still be given the labels of swell, even though? Nope. We talked a little bit about that. Do we have to capture run up from black spot? Yes, yes, we do. And am I even allowed to do that? We'll take a look. Do the medium look okay? All right. Let's start from if all the retentions are accounted for. So this one goes here, that one goes there. This one treated the plaza, plaza, plaza. And this diversion will need to be changed. I'm thinking we need a couple more here. Yeah. So that's one. Yes, that's one. And at least one more. At least one more. Let me draw it better. Like this. Okay, so that one goes over here. Cool. Yeah, in this case, I would ask for one more over here and one more over there. Reason being that needs a connection, and your first connection is over here. And this is a big area, so let's break it down to 3. And that one is okay. And this one goes into here. Depending on how big of an area there is. Looks like if you do a quick estimate of how big this is, and if this is, oh, you have one more over here. Oh, so then you have enough space. You can use 1/12 as an estimate for required retention area. So I think that's enough space. Except for these, I think you're okay. Yeah, you're right. $20? Is it 20? Is it 20% slope? Yeah, if you increase to 25, then you have a little bit more space. Mm-hmm. Ideally, we would try to do that. Yeah, the 107 is okay. Yeah. And we're trying to do, it's this area that's a little tight here. So what we can do is we can close it off and do something like this. Tiny, tiny little space. And we might be able to gain some space in this way. Not a lot. That one you're probably able to, so we're walking Oh, the ADA, if your ADA is over here, if you have enough ADA, then I'll get rid of that ADA. And then I wouldn't worry. If I get rid of the pavement here, then you don't need another one there, right? Yeah, I think if you can squeeze one in, that'd be great. If not, then we'll just use this space. Go away, ADA. Okay. So, well, is this middle area also a retention area? No, okay. Mm-hmm. Yeah. 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 Right. Have you used 2 feet for the curb? Yeah, that's why. The entire width here is about 5, maybe? Yeah, it's about 5 foot. Yeah, that's too narrow. Yeah, yeah. Okay. And that actually makes it more important to get rid of the pavement over here. Yeah. Here you wouldn't need, do you mean these 2 sites? That seems okay to me. Because this one is above, right? I mean, the elevation here is high, so I don't think that's a, but no, if you have ADA here, it's the same thing. You would need a sidewalk. So the sidewalk needs to go like this, which you totally have space for. So I'm not concerned. This is the boundary, the 4, right? Oh, okay. So you have that already. In that case, go. Water comes in that, yeah, you don't need a lot of space over there. So cool. All right. I think that works. This is that one. And then they go up there and then, okay. I don't think there's an issue there. This one is okay. Get rid of that pavement there. If you really want to make more ADA space, you can have the same option of putting it there and having a raised walkway over. A little complexity, but overall, you give people the option of, if I parked, I can go over here. That makes it more justified to have the medium here be a walkway, right? Otherwise, it's basically pavement, and you don't necessarily have to have that walkway, right? Yeah, if for, yeah, just if I can extend this over, actually that means I would also have a raised walkway across the bioretention area. Then this makes it more justified to have it. If this is basically just an elevated space and it doesn't lead to people walking over here, then you might as well remove it. Yeah, if it's not green, then it's not walkway either, then I don't think we need it. Then you can have more space over here. Yeah. It could. Yeah, it's just in that case we might want to give it a little more space to make it fun. Yeah. Mm-hmm. Zoom out. Ah, what did I do? Okay. Want to make it smaller and see if there's a bigger, better, larger scale strategy there. There's definitely room. There's definitely room to push this over a little bit if we want to. I think that wouldn't be too much of a pain. It means that we need to curve this back a little, but then that's not a huge change. If we want to do that, there's definitely room to make this smaller because this here, there's only one portion. Okay, take it back. Yeah, honestly, this big area, it's not performing a lot of function. If we want to push it thinner here and actually move the whole, cut a hole here instead, we are certainly allowed, so basically like this. I think that's not a bad design either. We can push it closer. This distance can be smaller, which actually make this smaller too. And then make this larger. You don't necessarily need to move this, but let's see. How about moving it up a little? I think earning more space for this one, it's probably the priority that I would choose. Mm-hmm. Yes. Yeah. Right. Let's not do this. I think this would incur more base map change. Systematically move it over by a few feet and shrink the parking spots and make it this bigger. And I think this only needs a couple feet as well. So I think overall, it's not going to be a huge base map change to get some more space for here and here. Okay. Let's take a look at this portion. Yeah, that's okay. One spot over here. Then this looks good. Oh, let me clear. I think that pretty much answers the questions. Anything else that I missed? Okay, cool. All right, good work. Hey, yeah, let me check back to see if anybody's actually, ooh. Huh, let me go back to the main room. Yeah, where is it? You.